All right, so inverse trig, functions, and differentiations, where we've taken the derivative of inverse trig. But before we go into the calculus with inverse trig, some of you probably want to know, how do we evaluate inverse trig? So let's refresh our memory. Okay, let's refresh our memory here. So for example, all right, the arc cosine of 0. All right. So for inverse trig, the inverse, right, so arc cosine is the inverse of cosine. That means if you want to cancel out cosine, you don't, like, so for example, let's say if we had like cosine of x equals something, if we want to solve for x in this situation, right, sometimes we just look at the ratio there and we're like, oh, we recognize the ratio, we know that x has to be like, pi over 4, pi over 3, whatever, whatever radian measure there. But if we don't know, so let's say we have cosine of x and it equals like, pi over 7, or not pi, pi over 7, sorry. Let's say it equals like, I don't know, 0.7 or something like that. And we want to figure out like when, cosine of what radian measure gives us 0.7. Well, that's not on our unit circle, right? We don't know 0.7. We could do 0.5, that's 1/2. We could find cosine, what x values when you take cosine of it give you 1/2. But we don't know what x values when you take cosine of them give you 0.7. So to solve this, right, to cancel out the cosine, we do not divide both sides by cosine, right? This is not cosine times x, it's cosine of x. So to cancel out a cosine, you do cosine inverse of both sides, or arc cosine is another way to write that. So there's, you could say arc cosine, or we could also, know this as cosine inverse of 0. Either one of these is acceptable, right? Those are equivalent statements there. All right, two different ways to see it. So in this case, we want to figure out what that equals, right? Does anyone know what that equals off the top of their head? So it's going to equal some number. Let's call it x. And actually what I should really call it, not x, but theta, okay? So with regular trig functions, the thing we plug in is an angle measure in radians or degrees, right? So we always take cosine of an angle in radians or degrees, and then we get a ratio. For the inverse, the thing that's inside, that order is flipped. Now we're taking the arc cosine of a ratio, and we want to get the matching then angle theta. So this is kind of like one way you can set it up. You start with your inverse trig, and then just let's say it's going to equal some angle theta. All right. And so again, to evaluate this, we look at it and like, I'm not really sure what arc cosine of 0 is, but I can rewrite this as then cosine of theta equals 0. All right. This is an equivalent statement. Arc cosine of 0 equals theta is the same thing as saying cosine of theta equals 0. We do cosine of both sides there. Cosine of arc cosine cancels out, leaving just the 0. Cosine of theta is just cosine of theta. And now, for those of us that know our trig, and if you don't yet, you need to get it down. I'm going to tell you it's not going away. Okay, it's going to be there forever. So in this class, so we need to have it down. All right. So cosine of theta equals 0. So that means theta must be what? Pi over 2. And 3 pi over 2. But we're only going to stick to that first answer there, cosine of pi over 2. Cosine goes from 0 to pi. The arc cosine only goes from 0 to pi. And then sine goes from negative pi over 2 to positive pi over 2. Okay. So yeah, cosine.
Not the same thing for a tangent.
Tangent, yes, it also goes from
negative pi over 2 to pi over 2.
Yeah, negative pi over 2 to pi over 2, yeah. Cosine 0 to pi for the inverse stuff. So there it is. So yeah, so it's only one solution. Theta is pi over 2. Okay, so there's that. All right, let's try another one here. So that was like A. We'll go to B. Whoa, I'm putting equals there. Sorry, that's weird. So like let's do arc tangent of the square root of 3. And if you like using those reference triangles, it might not be a bad idea to have those drawn. So I'm going to go ahead and draw those in here. So we've got like the pi over 4 reference triangle here. And I think, is it? A small size, okay, because there's multiple ways to write it, so I just wanted to do it the way you guys want. So it's, okay, 1 for the legs and then root 2 for the hypotenuse. And then the 30, 60, 90 triangle, or the pi over 3, pi over 6, and then that's going to be 2, 1, and then root 3.
No, I'm pretty sure though. I'm sorry. It's just root 3. Yeah.
Mm-hmm. The way I have it written there, yes. All right. So now I go to arctangent. Again, what is arctangent of root 3? What is that? It's going to equal some angle theta. So we can take tangent of both sides here. We're left with root 3 equals tangent of theta. If I go up here to my special right triangles, I see, aha, I can get root 3 by doing this side, root 3 over the 1 here. Okay. Tangent is opposite over adjacent. So tangent of which of these angles here is going to result in me getting root 3 over 1? The pi over 3, right? Tangent is opposite. So if I pick pi over 3, opposite that is root 3 over the 1. That's what I want there. So theta then must equal pi over 3. Okay, that's another way to kind of look at it there. Theta is pi over 3. All right, questions about how we got that? Do we need to, like, yeah, Todd?
Wait, so how did you go from the first line to the second line?
So arctangent of root 3, I never really bother, I guess, trying to figure that out. I rewrite it in terms of something I'm more familiar with. So I take tangent of both sides. Tangent of this left-hand side, tangent of arctangent, they cancel out, leaving just the root 3. Tangent of theta is then just tangent of theta. And then I say, okay, tangent of what angle gives me root 3? And that's where I go to my reference triangles to help me figure that out. All right, let's try another one here. All right, so let's do arcsine. Whoops, can't spell. Arcsine of -1/2. Okay, again, I don't know what arcsine of -1/2 equals. We'll say it equals theta, some angle theta. Which means that -1/2 equals sine of theta. Again, just taking sine of both sides there. Now let's not worry about the negative right now. Let's just focus on the 1/2. So sine of what? Well, sine is opposite over hypotenuse, right? So part of SOHCAHTOA. So again, going over here, it looks like I can get a 1/2 by using this right triangle right here. So sine of what? What's theta got to be? Which one's going to be? Yeah, it's supposed to be negative pi over 6, right? Positive pi over 6 will give us a positive 1/2, so we want negative then pi over 6 to give us that negative 1/2 value there. So we're going to negative pi over 6.
What is the interval we're using for
For sine and tangent, it's from negative pi over 2 to positive pi over 2. So it's like the first and fourth quadrants, basically. And then for cosine, it's the first and second quadrants. So 0 to pi.
So is it actually 2 pi, that's not 2 pi, not negative, whatever?
So what do you mean by it's not?
Pi was a bad example, like how pi over 6 in the first quadrant is positive with pi over 6. 11/6 pi was negative pi over 6.
Right. So
2/3 pi negative pi over 3?
yes. Yes. Or, well, not 2/3 pi. It would be 5 pi over 3. It would be negative pi over 3.
I mean for...
Cosine? For cosine, no, you would just go from 0 to pi. So you'd have to do like this. So, oh, I see what you're saying. Sorry. So, if you want, well, let me see if I got one. Do I have one like that? No. All right, we'll just do one. We'll just do one here. So A, B, C, D. All right, so we'll do arc cosine of negative root 3 over 2, we'll say, equals theta. Okay, so again, you're given this, you'll be given this kind of problem, okay? You won't be given the equals theta part. I like to put that in there and say, okay, our cosine of this ratio equals some angle. I don't know what that angle is. I'll take cosine of both sides. So negative root 3 over 2 equals cosine theta. Okay. So it's like, all right, let's not focus on the negative right now. Let's just focus on cosine of what gives me root 3 over 2. So cosine is, pi over 6 gives us the adjacent over the hypotenuse. So it's going to be pi over 6. But we don't want to use pi over 6 because that's in the first quadrant. That's going to give me a positive root 3 over 2. I need to go to the second quadrant. What's the pi over 6 measure in the second quadrant? 5 pi over 6. So that's the measure we want there. Okay. And that'll give us the negative. So does that answer your question now?
Yeah.
Okay.
I just don't see why we can use. I guess it's just because of the intervals.
Yes, it's because of the
So of why we can just say negative pi over 6.
Yeah, why we have to use a negative pi over 6 here, because it's only the first and the fourth quadrant. That's why.
I just feel like it'd be easier if we could just
Sure.
like
I'll write the
you
intervals
just
down.
say negative pi over 6 for the D as well.
For which one? For D?
D.
But negative pi over 6 would not result in negative root 3 over 2. Cosine of negative pi over 6 is still positive root 3 over 2. Because it's in the fourth quadrant and cosine's positive there. Okay? So that's the key. That's why the domains are slightly different there. Who want me to write down the intervals and stuff? Sure. So I'll put that down here somewhere. So, because I want to do a few more here. So basically for sine, okay, arcsine of something, and I think that's going to be also, so arcsine, arctangent, and then I think also their reciprocal functions, I believe. Those I'm less sure about. I think so, though. I think... That I'm not sure. Let me look those up real quick before I write that. Sorry? Well, the derivatives will be, not the domains and ranges, though. First function is 175. Sorry, folks, just one second here.
It's just like
Oh, fun. It doesn't say. All right, I will have to look that up because I don't have.
Mikey's your best friend.
Okay.
It's not Mikey. It's a girl at work.
I'm not sure. I'll have to take a look. I'll take a look and see because I don't have it. It's not in the book, unfortunately. I think I have to look in the pre-cal book. All right. So let's just say for right now, for the basic kind of functions, the range for these. I'll say the range, I guess. I guess we'll equal those. Well, not equal. Something like that. I guess it's equal. Yeah, it's equal. Okay. And then for arc cosine, its range is only from 0 to pi. So your answers will be from 0 to pi. Okay. All right. So you have that there. Again, I'm not too worried about that because I don't think we're going to be evaluating very much inverse trig because we're taking the derivatives of these things, but still it just has a good little refresher there. So we'll continue on here. I want to do a couple more. Okay. So let's look at another one here. Let's go like arcsecant, right? One of those reciprocal functions. Arcsecant of 2. Okay. So again, same thing. It's got to equal some angle theta. I don't know what it is, but we'll just say it's going to be equal some angle theta. Which means then that if I take secant of both sides, I get 2 equals the secant of theta. And again, I'm less familiar with secant, but secant is the same thing as 1 over the cosine, right? So if 2 is equal to 1 over cosine theta, that means then cosine theta is going to equal 1/2, right? Just do the reciprocal to both sides there. So reciprocal that, reciprocal that. So cosine theta equals 1/2, which we can answer, right? That means then theta will be what? What cosine of what gives us a positive 1/2? Okay, so we go back to our reference triangles up here. Here's a 1 and a 2. Cosine is adjacent or hypotenuse, so to make this the adjacent and then this hypotenuse, it's got to be pi over 3. Okay. I'm going to have you guys try one here on your own. Arc cotangent of -1. Let's go ahead and give that one a shot real quick. Arc cotangent -1.
Did you mean to freeze it?
Oh, I did. I didn't push the button down hard enough. Okay. Whoops.
I read 45 this morning in first class. I was like, hey,
no,
the library. Well, kind of. No. I just think. What is your thing about value on the
Not the cosine sine adjacent to tangent.
But that's not, no. But it's the pi value, like pi over 4, pi over 6, pi over 3, not 3.
Oh, okay.
So you got pi over 4, negative.
Yes. Hard. What is hard? Do you have a little sentence stress? You know, you're going over 8 class.
You bought them all, right?
Yeah. I told myself I have to have it read by class. So I have 20 pages to read.
Okay.
Myself.
Alright.
It's actually kind of not. It's not as bad as perfect that was. Are you just like wah wah? Yeah, he's like whining like a baby.
I like the amount of small details.
Yeah, like no one cares.
Horrible.
He's like on approximately 57.
Okay.
Stuff like phone. And the test like, what day did you spell?
So I got negative pi over 4.
Even though I got 96 on that test.
So cotangent of negative equals -1. I don't know. Again, cotangent I'm less familiar with, so I did the reciprocal to both sides, made that tangent of theta equals -1. And then when does tangent of theta equal -1? We can go back up to our reference triangles here. Okay. Tangent of none of these, tangent of pi over 3 or pi over 6, none of those will give us -1. But if you look here at pi over 4, I get 1 over 1, you know, like a tangent is opposite over adjacent, so 1 over 1, that's going to be positive 1, but I need to be negative, so negative pi over 4 then. Okay, we're going to go down into that fourth quadrant, end up with a negative 1. All right, so, other things. Oh, question. No, if you got it, you're good. You don't have to change it. That's just a strategy. Okay, next, we're going to use, so again, this is not calculus yet. But just some other things you can do with those inverse trig functions. Okay, so for example, let's say here, so if we'll do 2 of these. Given that y equals the arc sine of x, okay, I want us to find cosine of y. So given that y equals the arc sine of x, find cosine of y. Or what would cosine of y be equal to? All right, so, well, what do we know that y equals? Arc sine of x. So we could just say, all right, it's cosine of the arc sine of x, right? Isn't that what cosine of y equals to? Cosine of arc sine of x. We plug the arc sine of x in for y. That's it. So we could say that, and that wouldn't be wrong, but we can actually go further here. We can do more. All right, and I'll show you what we can do here. No calculus necessary. Nope, this is all pre-calculus still. All right, so to kind of like simple, because again, cosine of the arc sine of x is like, how would we simplify that, right? If it was cosine of arc cosine, then those would cancel, we're left with x. But since it's cosine and arc sine, these are not exact inverses of each other, and so they don't just cancel out and give us x here. But what we can do is, let's go back to this original equation here. Okay, y is equal to the arc sine of x, which means that sine of y equals x, right? If I take sine of both sides there, sine of y equals x. Sine of y equals x. Now, what does that mean? Well, that means that there's some right triangle all right, with angle y, right? We always take sine of an angle. There's some right triangle with angle y that when I take sine of that angle y, it results in a ratio of x, or x over what? What can I put x on top of? 1. X over 1, right? So, to recreate this right triangle, sine is what over what? Opposite over hypotenuse. In this case, sine of y then had better be opposite side, so x over hypotenuse of then 1, right? X over 1. That's where we kind of recreate that triangle from. Is using that ratio there, make it x over 1. Now, let's see here. So now I want to find cosine of y. We said that was the same thing as cosine of arc sine, but actually, cosine of y, well, there's y right there. I want to find cosine of that. Cosine is equal to what over what? Adjacent. I'm missing this adjacent side, though. Bless you. But how can we find that adjacent side?
Pythagorean Theorem? Yeah.
We got a right triangle, don't we? Got 2 sides of that right triangle, so we can come up with come up with an expression for the third side. Obviously, it's going to have x's and stuff in it, but we can still find like an expression for this third side. So yeah, so we'll do a little side work here. So I'm going to put that down below. So it's going to be a squared plus b squared equals c squared. Okay. So can I just put that 1 wherever I want to? Where does 1 have to go? In for c. It's the hypotenuse, right? And then that x, can I just put that wherever I want? Well, for the a and the b, right? Doesn't really matter. So I'll just put it in for the a. And then the b squared we're going to solve for there. So I'll I'll zoom in some more so you guys can see hopefully a little better. All right, so let's see. I got to get the b by itself, so I get b squared equals 1 minus x squared, and then square root both sides, so I get b equals the square root of 1 minus x squared. Okay. Oh, now good question. So plus or minus. In this context, do we want to have the minus? Why not? We're talking about the length of the side of a triangle, and so that wouldn't really make sense to have a negative length.
Doesn't make sense.
But it's good that you brought that up, because I was going to bring it up otherwise, Tyler. So square root, wait, not negative, sorry, yeah, see, now I'm doing this, sorry. So it's positive square root of 1 minus x squared to that side. Okay? So then if I want to find cosine of y, cozy, all right? Cosine of y, not quite cozy, right? It's z, but anyway. Cosine of y is adjacent or hypotenuse, so it's just adjacent side, square root of 1 minus x squared. Okay, over hypotenuse of 1. And that's the best we can do. Okay, because we don't know anything else about the x there. All right, so cosine of arcsine, right, that's kind of strange. That's not exactly how we want to end up. We want to end up with something like this then, because we can draw that, recreate that triangle there. Okay.
Could we put back sine of y into the cosine of sine of x, and they would just cancel out the cosine of x?
Sure. That one more time?
So like, because we now know that x is equal to sine of y. So
Right.
we've also done cosine of arcsine of sine.
Cosine of arcsine of sine. Well, but the arcsine went in for the y because y is equal to arcsine of x, but sine of y is equal to x. So you could have put the sine of y in for this x here, and it'd be arcsine of sine y, but then that would still end up with back to cosine y, because arcsine and sine would cancel, and still leave with y. Like, yes, you could put this, yeah, so you understand, the other cancels out back to where we started. Okay, B, let's try another one here, and then we'll move into actual calculus. No, not calculus. Right, not right now, we're in pre-calculus right now. All right, given y equals arcsecant of the square root of 5 over 2. Okay, find the tangent of y. Okay, so very similar to the last one. This one's nice though because we'll actually have some numbers and stuff, not like just x's. Okay, we'll have some nice numbers. But again, the key thing to kind of clue you in here is that we have y equals arcsecant of root 5 over 2, and then we want to find the tangent of y. Okay. Now, part of the problem here is that no one here knows how to evaluate arcsecant of root 5 over 2, right? We could type into our calculator, I guess, and get an answer, and then do tangent of that answer, right? These ones up here we knew how to do because we know, these ratios. These are familiar ratios here. But the ratio of root 5 over 2 is not a familiar ratio, okay? The ratio of x is not a familiar ratio. So, let's do the same thing we did before. We'll start by kind of like recreating a right triangle. So let's say we get secant of y equals then root 5 over 2. We take secant of both sides to kind of cancel that out. And then, again, I don't like secant of y. I'm not as familiar with that, so I can reciprocal both sides. And the reciprocal of secant is cosine, and then it becomes 2 over root 5. Okay, remember you don't have to rationalize that. You can just leave it as 2 over root 5. That's okay. So let's recreate this triangle then. We have a triangle we can make now. So let's see here. So I think I'm just going to draw this. It's not to scale, but it's got to be a right triangle at least. I'm going to put y right there. Okay. And then what sides do I know? If cosine of y is equal to 2 over root 5, cosine is adjacent over hypotenuse. That means this bottom side's got to be what? 2. All right. And then the hypotenuse is root 5. And so now I'm not interested in cosine though. I really want to find tangent of y. So tangent is opposite. Uh-oh. We don't have the opposite side. But how can we find it? Pythagorean Theorem! So 2 squared plus b squared, I guess I'll say, is equal to the square root of 5 squared. Okay, let's get 4 plus b squared equals 5. So b squared equals 1. So b equals plus or minus 1? Just 1. In this case, now in general, right, you do want to, like, don't forget, when you're in an equation setting, you do want to have that plus or minus, you're taking the square root of both sides. But, since the context, we want to have a positive, side measure for our triangle here, it's going to be positive 1. And so then tangent of y is opposite over adjacent. And so there it is. 1/2 is the answer. All right, questions on any of that? Now we're going to get into calculus. And we'll see if we have enough, I hope we have enough time, we'll see. Frankly, I feel like we're running short. All right. That's the stuff, right, that's the stuff that we should remember from pre-cal, right? Am I right? Right, okay. So I'm pretty sure you guys have seen that before. If you were in the wild, you would have been killed. Killed.
I've never worn a kill.
Me neither. One day, I'm hoping.
We should have a kilt day in the class. Everybody has a
Yeah.
I think you're right. Because nobody likes it. Why kilts? Because
You guys can either take a quiz or wear kilts.
maybe you have to talk to your ABBC friends. Implying you have friends.
If I talk to them about calculus, they'll just make me feel stupid.
Like, oh, you guys are only learning inverse trig.
Yeah, that's literally what they say every time. Yeah, they really do.
Then we ask them what's your grade? 54.
Yeah, no, they're like, yep.
So,
Not Mr. Witt. Calculus slow. 1. Calculus fast.
so here's one way. All right, I'm going to show you this one. I'm going to show you how you can derive this one, but take the derivative. But we're going to show you we can figure this one out, kind of, with some trickeration. So follow along with this, and then we'll get the actual, answer, okay? So, we want to take the derivative of arc sine of u. All right, so let's just start with something like y equals the arc sine of x. Okay, and that's kind of why we went over this stuff earlier, so we can kind of maybe follow along this argument about how how to take the derivative of the arc sine of something. Okay. So again, we're going to take the derivative of arc sine of u. We're going to start with a simpler one, just y equals arc sine of x. Remember, u could be, e to the x. U could be square root of x. U could be 2x squared plus 3x plus 1. It could be like a function in there too, right? U doesn't have to be just a variable u. It could be a function. We're going to start with the basic arc sine of x. So we know, okay, if that's true, that means then the sine of y must equal x, right? And we know how to take the derivative of this. We know how to take the derivative of this with respect to x, right? What's the derivative of x with respect to x? 1. So again, we'll just take the derivative of this, both sides with respect to x. I'll just take the derivative of the whole thing. I don't know if I'm supposed to write it that way, but then we'll just take the derivative of both sides with respect to x. So the derivative of x is 1. The derivative of sine of something is what?
Cosine.
Cosine of that something. So it's cosine y. But then because of the chain rule, right, we have to multiply by the derivative of what's inside.
1.
So what's the derivative of y with respect to x?
Oh, dy
Dy dx or y prime. We can just write y prime, y prime. Okay, that's implicit differentiation, right? Derivative of sine of y is cosine y times the derivative of what's inside, y prime. Okay, great. Well, that means to get the y prime by itself here, because that's what we're interested in, we want to take the derivative of this arc sine. So we want to isolate the y prime, so we'll do 1 over cosine y. All right, so it's okay, yeah, that makes sense. So that's the derivative then. You're saying the derivative of arc sine of u is 1 over cosine y. Well, not quite. We're going to do a little bit more trickeration here.
Is it though, like on a free response question, would that be?
No, I'm showing you. I'll get you there. We're not there yet. All right.
Give it a slow count.
Right, that's still true. Square root of a square, right? Why would I do that? I'll show you here in a second.
Because it's 1.
And again, this is just so you can see it here, okay? Equals this. I'm not making this calculus up. It does actually have, it does people actually came up with this stuff, okay?
And I
So,
call those
right, so that's a good point. Why do we use a square and a square root here? Because we know a Pythagorean identity,
Totally.
sine squared y plus cosine squared y equals 1, right? It has to, that's a Pythagorean identity. Or, because we only have cosine squared here, cosine squared y is 1 minus sine squared y. Ha 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 ha. I heard that, Christian. That was clever. That was clever. Just make sure you don't drink and derive. It's dangerous. Well, was he under the influence? We don't know. So I was not. Yeah, I was not trying to make that kind of. Anyway, so cosine squared is the same thing as 1 minus sine squared. But wait a minute. Why is that important? Because
Uh-oh.
what did we say the sine of y was equal to? Way back up here, it's x. That's the derivative of arc sine. 1 over the square root of 1 minus x squared.
Yeah, but so if you...
That's crazy.
Let me just work this backwards.
Sure. Back it up. No. Hashtag Mr. Wade.
So if you just...
Oh, at Mr. Wade. Whoa.
Picture of us driving like a Tesla.
Yes.
Are you gonna teach them?
Yeah, well, I mean, you need to know the derivative rule. The derivative arc sine of u. So let me actually just go through these now. Okay, so here we go. So the derivative of the arc sine of u with respect to x is 1 over the square root of 1 minus u squared times u prime.
So,
That's your derivative rule, yes.
so if you just go back up, so when we were doing the inverse trig function,
Uh-huh.
the
The x.
x
Yeah.
is
Yep.
so cosine y is root 1 minus x squared over 1. So then, if it was 1 over cosine of y, it would just be 1 over
Yep.
root 1 minus x squared.
Yep.
So why is
Because I wanted to show you it this way with the derivatives. Implicit differentiation and stuff like that. I wanted to show you how it's all the derivative. That's right, make you cry. All right.
Don't derive and drive, kids.
Arctangent
Derive.
is 1 over 1 plus u squared times u prime. Okay, I don't really have any cute or clever ways to memorize this. It's just straight up memorization.
There's no square root there.
Okay.
How many points?
No square root, that's right. How many points off if you don't memorize it? That's a great question.
Probably a lot, because
I wrote those two first on purpose. I think so, actually, yes, and because they're the ones you really need to focus on for knowing.
Uh-oh.
Times u prime.
Absolute values.
Yeah, it's supposed to be absolute values, yeah. Absolute value symbols, not brackets. Oh, just, I didn't use parentheses, I used brackets, that's all. What's that? Yeah.
Well, yes.
I mean, I do have it copied down, yes, I do. But yeah, I have them memorized. Yes.
Mr. Wood, give your guitar times u squared.
Minus 1, times u prime. Yeah.
You ever get tired of writing the same thing over and over again?
Well, you think about it, I only write it once a year, basically.
Very true.
Now, if I had this class twice, like I did last year, then I'd be writing it twice a year, which again, is not that big of a deal. Twice once a year. I do that with geometry, yeah, sometimes. It does get a little repetitive.
Something happened like...
All right, so then we also have, then of course, arc cosine, arc cotangent, and arc cosecant.
The value of these papers went up.
Times 2, right? Okay, so, but the good news is, arc cosine is just negative 1 over the square root of 1 minus u squared times u prime. And arc cotangent, anyone want to guess what that one's going to be? Negative 1 over 1 plus u squared times u prime. And then arc cosecant is negative 1 over absolute value of u times the square root of u squared minus 1 times u prime. Now, I'm going to star 2 of these. And I'm going to give you guys kind of like the, I don't know what I'm going to say, like the quick and dirty calculus, I guess. All right, so like
Quick and dirty.
within, so all of these are within the assessment limits of the AP test. However, the actual AP test, for the majority of the time, you only ever see arcsine and arctangent. And the majority of the time, it's arctangent first, and then arcsine second, and then arcsecant, like hardly ever. I don't know if I've ever seen it on the AP test before. So really, it's these 2 that you want to focus on knowing: arcsine and arctangent. Okay, and I will say on our tests, I will focus on arcsine and arctangent too. I will not give you an arcsecant. Okay, so I am not going to have you guys. Don't worry about these 4. Are they within the assessment limits? Yes. When it comes to AP review time, we'll look back over those, and stuff like that. But the big 2 you really want to have down are the 2 I have starred there: arcsine and arctangent. Okay, that is very doable, right? Yes, Mr. Widmeyer. Okay, good. Oh yeah.
Oh, yeah.
All right, let's use them.
You betcha.
You betcha. Oh yeah.
You betcha.
I know we're running out of time here.
Yeah, I agree with you.
No, I don't think it's the best.
All right, so Nate, what's our u here? The 3x. Right, so when I go take the arctangent, okay, the derivative of arctangent is going to be then 1 over 1 plus what?
3x squared.
The quantity 3x, very good, squared,
Times 3.
times u prime, which is 3. Beautiful, exactly right, that's it. Okay, so it's 3 over 1 plus 9x squared if you want to simplify.
No, we don't.
Yeah, you don't want to.
It wouldn't
I
be
don't
9x squared, it'd
want
be
to.
9. Oh, yeah.
Okay. Yeah, don't forget, the 3x is being squared, so it's both the 3 that gets squared and the x that gets squared, so 9x squared there. All right, let's try another one. B. Derivative with respect to x of arcsine of the square root of x. So let's see here. So Donovan, what's our u here? Yeah, square root of x. So we have to use a chain rule here, right? That's kind of why I'm using the idea of the u. We have a function within a function. We are taking the arcsine of something, and that something is a function itself, square root of x. So we should probably rewrite, before I take the derivative here, I'm going to rewrite this as arcsine of x to the what power, Donovan? 1/2. Great. Okay. And so then let's see, the derivative of arcsine, that's right up here, right? So it's going to become 1 over the square root of 1 minus x to the 1/2 quantity squared. And then times what, Donovan? You got it. That's it. Yeah. That's right. Okay? Okay. So, x to the 1/2 squared.
Can you please teach like that? For like a class period, just like after everything's finished.
I feel like people get annoyed by it. And I feel like I do say okay a lot,
No,
actually.
no.
And watching my own videos. Oh, okay.
Do that.
Whoops. 1/2 squared, sorry, it's just x then, right? So it's square root of 1 minus x. And then this negative exponent, that means we can write that as 1 over 2x to the positive 1/2, right? Then x to the negative 1/2 goes down to the denominator. Remember, we need to be able to simplify. No negative exponent, so there's that. And then we can still combine this together further, can't we? 1 times 1 is 1 in the numerator, and this 2x to the 1/2, I can put the 2, and x to the 1/2 is the square root of x, times the square root of x, 1 minus x, like that. Okay, you follow me so far? Okay, and then because these both are square roots, this x can go inside the square root there, and I can write it as 1 over 2 square root of x times 1 minus x if I want to, like that. Or I can just do x minus x squared too if I wanted to as well. You know, like, or... Either way, it's good there. All right. Question on any of that? All right, I'm gonna have you guys try one here real quick, and then this will be the last one, and I'll get you guys your assignment. I know it's like not that much time anyway, but. All right. I know I said that we won't see this, but I'm gonna have you try it anyway. So give this one a shot. Use your rules there. And don't forget to multiply by the derivative of what's inside.
Are you gonna like test the on that
I believe, I will check, but I believe I only have arc sine and arctangent on the test. To mimic what you can expect for the APs.
Ooh, this is go. Wait, no, it's not. That's cool. No.
Yeah, this isn't that bad.
No, that's just fine. Oh, never mind. Rip.
RIP. R.I.P. in peace.
Rip and pepperoni. Original pizza.
2 over e to the 2x minus 1.
E4x, because it's a whale.
I like never simplified.
You
Really probably did that sometime.
I got 2 e to the 2x minus 1.
It should be 2 over e to the 4x,
Yeah.
because it's 1 over absolute value of u times square root of u squared.
All right, so
So u squared is...
Josh, got an answer for me? All right, so hang on, sorry. Let me see what's that right here. Okay, so like equals. So you said 2, like in the numerator. Okay, so 2e to the 2x. Absolute value of e to the 2x, right? Square root of. Okay, what do you think there, guys? We can simplify some, can't we? Now, so this is right, though. This is you took the derivative. That's all I asked you to do is take the derivative. So you answered the question. That's right. Okay, so good job. Now, we can simplify some here. First of all, inside the square root, right? E to the 2x squared. How do we simplify something a power to a power? How do you simplify that? You multiply. So 2x times 2, 4x. So square root of e to the 4x minus 1. Now, can we simplify anything else in here?
Yes.
What?
E to the 2x into e to the 2x.
Can we though? This thing's in absolute values, and this one's not.
If you just take the absolute value of it, you have just 2x
So yeah, so absolute value of e to the 2x. E to the 2x, will that ever be negative? It's not, right? Because so that's key here, right? To be able to realize that e to the 2x, absolute value of e to the 2x is the same thing as just e to the 2x. In this case, because e to the 2x is always positive, so absolute value will it's still positive, right? E to the 2x will never be negative because you're always plug numbers in here for x, and a positive number raised to any power will always still be positive. So we now have this, and we can cancel out those e to the 2x's. And so yeah, the final answer we can put is 2 over the square root of e to the 4x minus 1.
Can you move the...
Yep, sorry. Oh, down? Like how far? Okay, you good? So that's the final answer there. All right. We'll stop there.